So today we're looking at just using the Pythagorean theorem in other things. So hopefully you're doing pretty well with the a squared plus b squared equals c squared stuff to know how to use it. Because if you look over here at this, what they're wanting you to do is figure out, how tall that is. How big is the ladder? Well, it looks to me like it's an A here and a B here. And it's supposed to be an A. And then a C over here. So that should be just like the others. I think that's a lot like what we've already done. I don't think it should pose too much of a problem. Let's see what else we have down here for examples. Ooh, wait a minute. So again, this one, there's a little story to tell and everything and cute pictures, but really what it comes down to is you have an A, and there's the B, and there's the C. So this one, you remember, is how we said, we have this 144 for c squared, and this is going to be 100, and then that's going to be b. So it looks like we're going to have b squared plus 100 equals 144. So in other words, I subtract 100 from each side, I have b squared equals 140. Equals 44. And then I'm thinking, and hopefully you're doing it right now while I'm looking for my calculator here on my phone, and I'm going to do the square root of 44, and I get 6.6. Oh, hey, look, there it is right there. If I'd look there too, I'd see it there. So should be about 6.6. Let's see what they have down here. Sure enough. Now you notice they do say plus or minus 6.6, because when you take a square root, it could be 6.6, negative 6.6 times negative 6.6. So that's something to think about too, even though right here it just says length can't be negative. So there you go. And here's part 2, because I keep getting bumped off today when I do these. So the thing that you need to really pay attention to is, what are they asking for? And they're going to try to confuse you with things like this too. And you have to just be able to see that, here we have this and that and that. And they do give you, if I can erase this, they do give you that 8. And, I know that this is 11, and this part right down here is 4. I think that's just there to distract you, because I don't think you really need any of that. Now over here, I'm thinking we have a 12, and then we know that this, I'm surprised there's not a line there, but the radius there is 9. So again, there's nothing here that's too strange or surprising. Let me erase my lovely coloring. There we go. So everything you do, you should be looking to see, how are they using the Pythagorean theorem? Now you can, you should be drawing pictures. Like when I look at this one here and I don't see a picture, I'd be drawing a picture. All right, let me take a look and see if there's anything really weird here on this page. You don't need to do this one, how to use it. We don't need to do that. We know what we're doing there. You don't need to do 8. Number 9, you could do this, just which one doesn't belong. Like I can see, we know this one's a Pythagorean triple, so you should try to figure out if the others are Pythagorean triples or not. This one's interesting just because, they want to know how much space is left there at the top if you have that. So, to me, what they're really asking on this one is there a way to figure out this much right there? And there is a way to figure that out. So when you figure that out using your Pythagorean theorem, you should be able to tell me how much is left at the top, right? I hope so. And that's generally everything that you're doing. And the other page too, the assignment's written down. I'm sure you'll be told what that is, and just do your best, and then we'll see how it goes. So that's it.